Let's look at three properties of logarithms that are going to make them a really powerful tool, mathematical tool for us. First of all, let's think about this. Let's just consider this situation where we're going to let x equal log base a of u and y equal log base a of v, and u and v, let's just say, are positive real numbers. Now, what I want to do, I want to convert both of them to exponent form. In other words, bring this a over and make it a base of a over here. So we have a to the x equals u, and over here, a to the y equals v. Now I'm going to multiply a to the x and a to the y together. And that's the same as multiplying u times v. See? Now, remember that when you have the same base, here you have a to the x, a to the y, you can just rewrite that as a to the x plus y. That's a property of exponents. Now that I've done that, I want to move this back to log form. Okay, so it's going to be log base a over here, x plus y equals log base a of uv. Now remember, x, x is log base a of u. See, look at that. So I can replace x with log base a of u, and I can replace y with log base a of v. And there I have it. Okay, now look what we've discovered here. This is a property of logarithms, that if you take the log of a product, it's equal to a sum of the logs. See? Log of a u times v is equal to log u plus log v. Now, this is provided you have the same base. See, we have the same base here. So this is one of the properties of logs. Now, let's go back and look at this same thing. X equals log base a of u, y equals log base a of v. Let's convert these to exponent form, and this time we'll divide. Instead of multiplying a to the x times a to the y, we'll divide. So a to the x divided by a to the y is the same as u over v. Now, once again, we'll use a property of exponents to rewrite this as a to the x minus y. Now let's convert it back to log form. See? So it's log base a of u over v and x minus y over here. Now, likewise, notice x equals log base a of u and y equals log base a of v. So let's make that change. Now look what we have. You have log of u over v is equal to log u minus log v. That's another property of logs that we'll use. Now, let's think about this situation here. Log base a of u to the fourth. Think about what that means. We could expand that out. U to the fourth is u times u times u times u. Now, we just learned a sum property for logs, that log of u times v is equal to log u plus log v. So let's apply that here, and we get log u plus log u plus log u plus log u, right? This is a property that we observed earlier. Now notice there are four of these. 1, 2, 3, 4. So this right here, of course, is log u to the fourth, and this right here is 4 log u. See, there's 4 of them. 1, 2, 3, 4. So look what this is saying. These two are the same. And in fact, this is our third property that we're going to observe, that log base a of u to the r is equal to r log base a of u. It's like I just brought that r out front. And then we put those together with our other two properties. And these are three very powerful tools in mathematics that we'll be using.